Hello and welcome back to Chapter 9. Today we're going to look at Section 9.2. This is the first part in the 9.2 videos, and specifically we're going to be looking at the unit circle and its functions. So when defined, trig functions are usually referred to as what we call circular functions, and that's because they're all based on this little circle here that we call the unit circle. And we can use this unit circle to define circular functions for any real number s. Now, a couple things to point out about our unit circle is it is a circle that has a center at the origin, and the radius is going to be exactly 1 unit long. To measure an angle, what we're going to do is we are going to start out here at the point 1, 0, and we're going to measure the arc counterclockwise. The counterclockwise direction indicates a positive angle, whereas if we want to measure a negative angle, we would go in the clockwise direction. So a few quick things to look at on our unit circle. We have 6 different trig functions that we can analyze, and our first one is going to be the sine of s. Now sine s is going to equal y. We have the cosine of s is really going to equal x, and the tangent of s is going to equal y divided by x. And this is for values when x is not equal to 0. Now, as I mentioned in class before, the way I remember sine and cosine is if I have a coordinate point, x, y, x and y are alphabetical, just like cosine and sine. So I know cosine has to go with x and sine has to go with y. Now with these 3 basic trig functions, we also have their reciprocal functions. In their reciprocal functions, the reciprocal of sine is going to be cosecant, or CSC. So the cosecant of s is really going to equal 1 divided by y. The reciprocal function of cosine is really what we call secant, and secant s is going to be equal to 1 divided by x. And the reciprocal function for tangent is going to be what we call cotangent, and cotangent of s is going to equal x divided by y. Now, one little thing we need to make note of on all of our reciprocal functions is cosecant is defined when y is not equal to 0. Secant is defined when x is not equal to 0. And cotangent is defined when y is not equal to 0. An important trig identity that we're going to utilize a fair amount is it follows like the Pythagorean theorem. If I told you that I had some point xy here, and I wanted to find the distance from the origin to that coordinate point xy, I would take my x values and square it, and then add that to my y squared, and that should give me this distance 1 here. So you can see we have x squared plus y squared equals 1. Well, the same thing holds true when I'm dealing with trig, except instead of having an x squared and a y squared, my x is really going to equal cosine, so I end up with cosine squared, plus my y squared is really going to become sine squared, and these are both going to equal 1 because, again, that radius on my unit circle is 1. So this right here is an identity that I would probably start to memorize. So if I come here and I sketch a unit circle just to have something to look at, I know that my positive x will go all the way up to a 1, and my negative x values will go up to a negative 1. My y values will go to a positive 1, and they go as low as a negative 1 as well. So for my domain, notice that my x values will go in between a negative 1 and a positive 1, and my range will go in between a positive 1 and a negative 1. So for your domain and range, you have all real numbers between negative 1 and 1. So you can see that for any value of s, the cosine and sine are going to exist, so our domain will be all real numbers. Now for tangent, remember, is really equal to y divided by x. So with that being said, I know that tangent is not going to be valid or defined at values of x that are equal to 0. So this is going to occur when x is a plus or minus pi over 2, because again, if we just sketch a unit circle real quick, so my x values are going to be a 0 at a pi over 2 value, and I also have 0 on my x values at 3 pi over 2, and any increment of a pi over 2. So our domain then for tangent is going to be all real numbers except when we have multiples of 2n plus 1 times pi over 2, because we know that pi over 2, anything that's going to take us from pi over 2 to 3 pi over 2 and keep bouncing us around is going to make that denominator 0, or that function undefined. Now, if you recall, secant s is really equal to 1 over the cosine value, or the 1 over the cosine of s. So that really means that it's equal to 1 over x, since cosine is really an x value. So secant is undefined whenever x is going to be 0 in the denominator. So our domain is going to be the same as the domain of the tangent function. It'll be all real numbers except increments of pi over 2 or 3 pi over 2. For cotangent and cosecant, we have cotangent is equal to x divided by y, and cosecant is really equal to 1 divided by y. So because both of these are a y in the bottom here, I know that my function will be all real numbers except for when y is equal to 0. Okay, so y cannot equal 0. And if that's the case, when I look at my unit circle, I get y values equal to 0 at 0 and pi, or any increment thereof. So just to kind of reiterate, the domain of our functions for sine and cosine is going to be all real numbers. For tangent and secant, it's going to be all real numbers except when we have increments of pi over 2 or 3 pi over 2. And cotangent and cosecant are going to be all real numbers except when we have increments of pi. Okay, now before we said that tangent of s was really equal to y divided by x. So what we're going to do now is we're going to go and we're going to take this y and we're going to substitute an s in, and we're going to take this x and we're going to substitute in the cosine. So what that's going to give us is tangent is really equal to sine divided by cosine. Well, if tangent is sine divided by cosine, that means cotangent has to be cosine divided by sine because they're reciprocal functions. We said that secant was really equal to 1 over x. Well, x is really cosine, so secant really actually gives us 1 over cosine. And then for cosecant, we said cosecant s was really equal to 1 divided by y. Well, y is really equal to the sine of s, so we can also say that cosecant is equal to 1 over sine. We also have two identities that are going to be beneficial for you to know. These will be one of the three that I kind of asked that you memorize. The first one was sine squared plus cosine squared equals 1. The next one says that if the cosine of s is not equal to 0, then we know that 1 plus tan squared equals secant squared. And if sine s is not equal to 0, then we also know that 1 plus cotangent squared equals cosecant squared. These statements are identities, or something that is true for all values in the domain of whatever variable we're given. So for next example, it says, for each number s, determine the point on the unit circle to which it corresponds and the circular function values for s. State which functions are undefined. So the first thing I want to do is I have to find 0. Well, 0 is going to be my starting point right here. So really what I'm going to look at is I'm going to look at taking the sine of 0. And the sine of 0, that's really my y value at this coordinate point here. So my y value at that coordinate point is going to be 0. I know if I do my reciprocal function, or I go 1 over the sine of 0, this really gives me 1 over 0. And 1 over sine is really cosecant. So the cosecant of 0 is going to be undefined. After sine, I have cosine of 0. Well, the cosine of 0 is really what my x-coordinate point is here at this point, or 0 degrees, 0 radians, and that's going to give me a value of 1. So my reciprocal function of cosine is actually cosecant. So the cosecant of 0 is actually going to give me the reciprocal of 1, which is also 1. And then I have my tangent function, and the tangent of 0 is really equal to my sine value divided by my cosine value. Well, sine was equal to 0 divided by my cosine, which is 1. So my tangent is going to equal 0. Now the reciprocal of tangent is cotangent. So the cotangent of 0, instead of being 0 over 1, is going to be 1 over 0. So that tells me then that my cotangent is going to be undefined as well. For part B, I'm going to look at pi. Well, pi is this coordinate point right here, the 180-degree mark. So the sine of pi is going to equal 0 because my y-coordinate at this point is going to be 0. The reciprocal, or the cosecant of pi, is really going to give me 1 over 0, which means that this is undefined. If I go and look at my cosine of pi, at this coordinate point here, my cosine is really equal to a -1. The reciprocal of cosine is secant of pi. So I really end up with 1 over a -1, which is a -1. And then my last one is going to be tangent. So the tangent of pi is going to be my y value or my sine value. So this is really sine over cosine. Well, for my sine, we said that my sine value was 0, and my cosine value was -1. So that means my tangent is really 0. And then when I go to do cotangent, cotangent is really going to give me cosine over sine. And cosine, we said, was a -1, but my sine was 0. So that means my cotangent is going to be undefined. For 3 pi over 2, 3 pi over 2 is going to fall 1, 2, 3 pi's over 2. So that's going to put me at like the 270-degree mark. So the sine of 3 pi over 2 is really my y value on my y-axis. And that means that my sine of 3 pi over 2 is going to give me -1. The reciprocal function of sine is cosecant of 3 pi over 2, really equals 1 divided by -1, or a -1. For my cosine of 3 pi over 2, on the y-axis, my x values are equal to 0. So that means my secant of 3 pi over 2 is going to equal 1 over 0, which means that it's undefined. And then my last function I have to find is my tangent of 3 pi over 2. Well, tangent is really equal to my sine over my cosine. and my sine was a -1 being divided by my cosine, which was 0. So that means my tangent is undefined. And then if I have cotangent of 3 pi over 2, cotangent is really cosine over sine, which really gives me 0 over -1, or 0. And finally, for part D, we have a negative pi over 2. Well, remember when we have a negative degree value or negative angle measure, we actually go clockwise. So a negative pi over 2 is really going to fall down here, and I have the sine of a negative pi over 2. That's going to give me -1. The reciprocal of that, or the cosecant of a negative pi over 2, is going to give me a -1. The cosine of a negative pi over 2 is going to equal 0. And the the secant of a negative pi over 2 is going to be 1 over 0, or undefined. And last but not least, we have the tangent of a negative pi over 2. This is really going to be my cosine. Cosine was 0 divided by my sine, which was -1. So my tangent is 0. And then last but not least, I have my cotangent. Well, cotangent is really the reciprocal of my tangent. So if I end up with 1 over 0, this tells me that my cotangent is going to be undefined. This is going to wrap up the part 1 video. Please come back and watch the part 2 video on section 9.2. Thanks and have a great day.